Hello, my name is Todor Plashko from Bulgaria, and in today's lesson we will finally start creating some tube and pipes, elastic tubes. First of all, of course, we have to make two little parts, the two parts that we will make the tubes between them. So this is where we were at the last lesson. We will create a part. Let's say I'll call it element 1, it doesn't matter at all. Element 1, a standard IPT file. Okay, we will start it from here, from the bottom of our table. Let's say create a 2D sketch. Right now the new element, it's not associative, but when we use some of the other let's say objects from previous parts, as you can see, the sign, it is now associative, adaptive to the changes that is made in the other parts. I create the 2D sketch with the circle in it, 250 millimeters in diameter. Then I extrude it with 30 millimeters. Okay, the next thing I will do is just I will create another sketch and I will project in it one of the holes from the previous part. Finish the sketch and then just use again the hole command to create the other hole, or use extrude with cut, no matter though. Alright, that must be the final result, and after that, of course, I will make a circular pattern of this hole. So I select the command circular pattern, select the hole, and for a rotation axis I just use some of the cylindrical faces. If you don't remember, the number of the holes is 12. Okay, of course you can do such a cylinder from the new commands in Inventor 2014 cylinder command. It is, let's say, a combination of circular sketch with circular in it and extrude command, 2 in 1. It's nothing different, as you can see on the left, extrusion 2. So the height of this cylinder is 400 millimeters. Then I will use a work plane, a plane that is exactly at the it sliced our detail. If you want to visually slice your detail, not removing material, just remove material for the reason of your sketching, use the slice command or press F7 from your keyboard. So I will need a few reference objects, not much. I will create four circles, something like this. Is the first one from the center, of course, 25 millimeters in diameter. Another one which is concentric to the first one, 60 millimeters, and the distance from the center, I think it's 25. Let me check. 25, yes. Okay, the next one, you can press the circular pattern, and if you move and press the tab button a few times, you can enter the exact distance from the first reference point you have started your, let's say, movement of the cursor. The second one, the same figure, two concentric circles. If you can see the distance we have entered is 60 millimeters. Alright, you see it, 60 millimeters. So everything is absolutely correct. I said the second circle also. What's 60 millimeters? Okay, I finished the sketch, and next thing I will do is just extrude the ring between these two circles. This one here it's not always necessary to see a perfect geometry. Just let's say go somewhere near it and Inventor will find it. Okay, the height, let me check it. We need a little bit over the cylinder, something like this. Alright, so that's that. That's the 2 points, let's say, where we will connect our two tubes, elastic tubes. Let's say the element 2 will be a sheet metal part, so I create a sheet metal part with a create button. Alright, okay, I will create it on the smaller side of my table. I will start by creating sketch. It will start somewhere here. Alright, I would just need a few I would just need this let's say edge. I projected it with the project command. Then I will just create an L profile, something like this. Of course I should put some dimensions on it. Of course I can put these dimensions after before during the creating of these dimensions. Alright, so it's 70 to 100. Of course I have to center this part of this geometry. Let me see if I can do it this way. No, I cannot do it, so I will have to delete this reference geometry. If you cannot delete it by selecting it and the delete button, you have to find it through the sketch. Sometimes when the projected geometry is somehow let's say constrained, let's say it's constrained to some of the working geometry we just created, it cannot be deleted by the delete button. You can find it. Okay, then I project this circle, and just as I said, I have to center my geometry, because right now my geometry, I have deleted the reference geometry, so it's absolutely not constrained. So I am using the horizontal and the vertical constraints to constrain it, and that's all. That's what I need. Then in sheet metal defaults, I put the 3mm thickness of my sheet metal that I will do, and then I just use the contour flange command. These lessons about tubed pipes are not for sheet metal design, so I will not create something very complex in sheet metal. I have few other lessons about sheet metal. Let me just check if this is the correct detail. Of course it's not. It must have more depth. Let me just use the tools from the inspect menu, the distance between here and here, it's 50mm, because this detail, the sheet metal detail, must be not this button, but the button here. If it's not open, click next to cancel, the button next to cancel, and it will be this additional information will be displayed. Let me just hide some of the unnecessary work geometries. Okay, don't bother that sketch, it's not so important. I will delete it. So the height is 125, not 50. Okay, I will create a sketch on this part and just and then I will create a cutting line. Of course I can use the chamfer command, I will show you later. And the distance is this, the vertical distance is 48mm. Let me check, 48, yes. And the other one is I think 62, yes, it's 62. this cut will be you see what's the purpose of this cut later. The next thing is to create some holes in chamfer, two chamfers here, two holes. Here, of course, I'm using the middle point of the lower edge for a reference point. The distance is 25, so always use the middle point. It's easier because you don't need to enter another dimension. So again, 25 for two holes. We need two holes. That's right. And finally, the finished cut of this sheet metal is corner chamfer here and here. Of course, I could use it for the first cut. It doesn't matter. Alright, so that's it. That's the parts. Okay, finally we will start creating tube and pipes. From the environment tab, select create tube and pipe. Tube and pipe. First, let's give some name of let's give a name of these tubes. It doesn't matter at all. And first run, its name will be, let's say, elastic or hoses, whatever you desire. So let's say the first name is, this is the assembly code, all the tubes, and the second one is the part of these tubes is the first I will create is the elastic parts, elastic tubes. Of course, it's in Bulgarian, but you can use other languages. Okay, so first in this elastic assembly, let's say I will place an elbow from the content center. It is this elbow that I will use is in tube and pipe fittings, elbows, and one I will use in later videos. I will change it, but right now I will use let's say Parker male elbow 409F to 249F. Okay, the two diameters I will use, the inner and the outer diameter. If you want to later customize this part, you have to select as custom, because if it's standard you cannot, of course, place it. Alright, so I placed it somewhere, then I click the command connect fittings here. I select this, the first part, the first hole or the first entrance of this elbow, and then just place it on the right place, place it on the right point. Then right click on it and select edit fitting orientation, so we can change its orientation like this or whatever you want. Alright, so this is the start point and this will be the end point. So the next thing, I go to tube and pipe styles right here. They are all the styles that are originally created in Inventor. I'll use the second one. Just right click on in flexible hose, right click on hydraulic hose, female thread, right click and activate. Later in the other videos I will change it. I will create your type of a customer type of standard. So click on hydraulic hose, edit it, and change the diameter to 3.38 inches. Okay, then click the new road button. Yeah, name it somehow. Let's say in this tube and elastic tubes, I will the first elastic tubes will be let's say the lower elastic tubes, it doesn't matter at all. Then road, select road and start from here to here. Okay, Inventor suggests you some trace. You can accept it, or as you can see in the second road, we will change it. Okay, I again press new road, then set a road, and the two points, the starting and the end. Okay, so that's the trace Inventor suggests me. Of course, this trace does not it's not very good, so I will change it. I will just select a few, let's say, nodes that I will later I will move them so I can change the trace like this. So I have 2 points, start and finish, and 2 points on this trace. Right click on the point, not on the trace, on the point, and select 3D move rotate, and then just move with the just move it using some of the grips or everything you want. If you want to add additional nodes, just use the command insert node, and again right click on it, and select 3D move rotate and orientate it whatever you want. Of course, as you can see, it's a very free looking curve, so, and I'm sure that your curve will not be the same, so it's let's say it's different case for everyone. Alright, something like this. Of course, you can add as much nodes as you want, and you can also use a previously created 3D sketch, not 2D, only 3D sketches. Right, something like this. And the final thing is populate road with hydraulic hose. This is my standard I have created. This is the 2 roads. Just select OK, and you see what will happen. Alright. Of course, if you don't like the result, go again in the road, change, add nodes, remove them, and something, and change the 3D, change the 3D sketch, the 3D trace. Finally, I will just show you that you can always edit a previously created part. I just change the diameter of the hole so the second elastic tube can move free, can pass free through this detail. So that is for the third lesson of our tube and pipe design. In the next lesson we will create a rigid type tubes, and we will create our custom standard.